In this lecture, we want to add up a bunch of other operators that could make our box containers much more flexible to work with. We want to have a compound addition operator, and this is what we have here. We want an addition operator to be able to add up box container objects, and we want a copy assignment operator. Let's look at how some of these operators might work. So suppose we have two box objects as we have right here. We have box 1, which contains 1, 2, and 3, and box 2 contains 10 and 20. So what we could do is do an operations like this and say box 2 plus equals box 1. And what this would do is add box 1 to box 2, and what this means is just taking the data from box 1 and add that to box 2. So 1 could be here, 2 could be here, and 3 could be here. And the result of this is going to be stored back in box 2. So we are going to end up with something like this. Box 1 is not going to change because we are just copying from it. But the result of the operation here is going to be stored back in box 2, and it will change. So this is the result we will have. This is what we can achieve with a compound addition operator on our collection type. We also want an addition operator, which is going to just add up two box objects and return a copy. So we will have something like this. We will return a new box if we add up box 1 and box 2. And the new box is going to contain all the data in two boxes. So the data from box 2 is going to be n, and the data in box 1 is going to be n. This is what we achieve with this operator. Now that we have seen how these operators could work, here is a possible implementation for our compound addition operator. It is going to take a second operand by reference. It is going to be a box container object. And the first thing we want to see is if the current object can contain all the elements of all the two boxes combined. So we check and see if the current capacity is enough to contain all these elements, and this is how we do it. We check and see if the current size, adding the size of the other operand, is not greater than the current capacity. If it is greater, we are going to call our expand helper method to expand our capacity. And then we're going to be copying data from the second operand and putting that in the current elements, starting at the last index in our collection. This is what we are doing here. If you look at our illustration again, if we do a compound addition like this, we will start at the last index. So at this moment in box 2, we have two elements. So we will start at index 3 and start adding elements from index 1. So we should start and put this element starting at the size index. Here the size is 2, so this is index 0, this is 1, this is 2. This is where we are going to start, and we need to account for this in our code. So we are going to do that here. You see that we start from m size plus I, and that's what we do here. And we will start with I being 0, so this is going to start an index, and this is going to add our elements in. This is going to copy the data we have in our second operand. After that, we are going to update the size of our current object, and the size is going to be the compound size of the two collections, and that's going to be stored in our m size member variable. This is how our compound addition operator could work. It is a member function here, and we can set up a plus operator as a non-member because this is just much easier. So we have a left operand and we have a right operand. We are going to set up a box container having a capacity equal to the sizes of two boxes combined, and we are going to compound add left and compound add right. And this is going to have a copy containing all the elements, and we can return this copy to be used by whoever called this operator here. We also need a copy assignment operator, which is really not going to be that different from our copy constructor. It is going to check and see if we are not trying to self-assign. This is a safety mechanism we have here, and we will check and see if the capacities are not equal. If the capacities are not equal, we know that we need more capacity, so we will set up a new dynamic array, and it is going to have the capacity of our source object we are trying to build from. And we will delete the current array and make the current array point to the new array. This is what we are doing here. And we are going to upgrade our capacity to be the capacity of the source object here. After that, we are going to copy all the elements from source and store them in our object. And this is how we do that here. And we are going to upgrade our size. This is how we can do this. Now that you know these things, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder, and our current project is other operators here. We are going to grab the code from the last lecture and use that as a starting point and make our collection type better. And we are going to put the code in here. So let's open this up in Visual Studio Code by dragging and dropping here. And we will open up our box container class and add a few more methods. The first thing we want to do is to put in our member implementation. So we will have our plus equals operator and our copy assignment operator. And we will do our plus operator as a freestanding non-member function here. This is what we do. Okay, with this in place, we can head over in our CPP file and put in their implementations. We can go all the way to the end of our file. You can see that it is really growing larger. This is probably the biggest project we had a chance to do in this lecture, and I am really proud of this. So let's do box container, and this is going to be a member of box container. This is what we mean here. And this is going to be the same, and we can put in our body. Let's do that. And our plus operator is a freestanding function, so it is not a member. So we can just copy its implementation. Let's say box container here. And we are going to put the implementation here, and we're just going to put a body in. We can do something like this. Our compound addition operator is going to be exactly what we saw in the slide. So let's put this in here. And we are going to check and see if we have enough capacity. If we don't, we are going to expand our collection. And after that, we are going to copy the elements from the operand here and store them in our collection. This is going to grab all the data and put that in the current collection. And we are going to increase the size to take into account the new elements that we just added from the parameter here. And this is going to do what we want. We don't need to return anything because this is a void member function. And we have an extra pair of braces here. So let's remove that. Our plus operator is going to be reusing our compound addition operator. So let's do that. We are going to set up a box, which is going to be a copy. The capacity is going to be the compound size of these two guys. So we are going to take one box, grab its size, and we are going to add the size of another box. This is what we do here. And we are just going to add the elements from each of the boxes here to our copy. So the result is going to be that all the elements are going to be stored in our result box here, and we're going to return it to be used by whoever called this function here. This is what we can achieve with this function here. The last thing we need to do is our copy assignment operator. This is going to be a little bit involved, but we can put the code in and follow it line by line. We are going to set up a pointer to a new dynamic array, which we might set up if we need more capacity because we want to store in another box container object which may need more capacity than we currently have in the current object. That's why we do this thing here. The first thing we do is check for self-assignment. If we are self-assigning, we're going to return out of this member function because we have no business really assigning to ourselves. We are going to check and see if we don't need any more capacity. If we do, we are going to allocate a new dynamic array. We are going to release the current array, and we're going to make the mItems pointer point to the new array that we just allocated for here. After that, we are going to upgrade our capacity, and that's going to be the capacity of the parameter that we pass here. Hopefully, this is making sense. And after that, we are going to copy the elements from the other object and store them in the current object. And that's what we do in this loop. And we are going to upgrade our size to be the size of the parameter that was passed in here. And this is going to achieve the action of copying one object and storing its data in another already existing object. Now that we have these things in place, we are going to go in our main CPP file. Let's see what we have. We can remove all the code here because if we build on top of this, this is just going to be confusing. So we can remove everything and start over and put in a piece of code we can use to test out all our operators. The first one is going to be our compound addition operator. So we will set up box 1 and put in 1, 2, 3, and set up box 2 and put in 10, 20, and 30. And we will compound add box1 to box2. What this will do is add the elements in box1 to box2. So we will have a box2 which contains 10, 20, 30, and 1, 2, 3. This is what we want to see here. So let's make sure we see this. We are going to put a separator here to make sure these things are separated properly. And we can put in a bunch of hyphens. Let's do that. This is going to do. And let's go down and do the same after our plus operator. This is going to be easier to follow. You can do something like this. And we are going to build and run and see this program here. So let's do that. We are going to run this through our GCC compiler. The build is going to be good, so we are successful here, and we can bring up a new window to run Rooster. And before our first separator, let's make sure we see everything here. Can bring this up a little bit. Operator compound addition. Okay, we have box 1 containing 1, 2, 3. We have box 2 containing 10, 20, 30. And after we do our compound addition, we're going to see that box 2 is going to contain the data it had, adding the data from the other box, which is box 1 here. And this is what we can achieve with this kind of setup here. We can also use our plus operator. And the way we do this, we're going to set up a new box, box 3, and we are going to add up box 3 and box 1 and print the result of that here. So we will see this printed out on the console, and we will look for box 1 plus box 3 here. So let's build and see this. We can pass this through GCC. I think we had already built this, but no big deal here. Clear and run Rooster. So for operator plus, we are going to see that box 1 plus box 3 is going to be containing all the data from these two boxes. We have box 1, 1, 2, 3. We have box 3 containing 81 and 82. And box 1 plus box 3, as you see here, is going to contain all the elements from box 1 and box 3. And notice that this is a copy that we are printing on the fly in our output stream statement here. This is really cool. We can also do copy assignment. So we can take box 2 and assign that to box 3. And if we print box 1, box 2, box 3, we're going to see that this has been assigned to box 3. Let's bring up our terminal window because I think we have the data in. So for our assignment, we have box 1 containing this data, box 2 containing this data, and box 3 containing the data, 81 and 82. And after we assign, let's see the assignment we did again. We assigned box 2 to box 3. So box 3 is going to contain the data we had in box 2. And if we go here, we're going to see that box 3 now contains the data we had in box 2. And this is what we have achieved with all these operators we implemented in this lecture here. This is all I had to share in this lecture. I hope you found it interesting. Again, these operators are not really confusing. All you have to do is know the mechanics of how operator overloading works. If you are confused about this, please go back and watch the chapters on operator overloading. And if you still have a problem, please ask. I will do the best I can to help you out. We are going to stop here in this lecture. In the next one, we're going to try and zoom out and see some similarities between our collection type with some standard library collections in C++. Go ahead and finish up here and meet me there.